Hey, we are going to review for the algebra test.
Woo! I
Okay,
love a test.
I love a test too, because it shows what you know. All right, so the first example, the graph shows the height of a kite flying for a certain amount of time. What are the variables? And describe how the variables are related at each point on the graph, or at various points on the graph. Okay, well, variables are my
Super easy.
X and Y axis, time, and height. And I'm totally cool with just time and height.
That's what you
You know,
write.
That's it.
Mhm.
Okay, so now I need to talk about how are these two things related.
Okay.
So what do you see first?
Well, again, it was a kite flying. So the kite starts not at ground level. Why do you think it doesn't start at ground level?
Well, because it's not down at zero. It's not at zero height.
Right.
And
So
because
you're holding.
the dude's holding it.
So you can say you're holding the kite.
Mm-hmm.
It's apostrophe.
Mm-hmm.
Holding the kite, and then you release it, and it flies into the air.
Yeah, I think it looks like it goes up pretty quick too.
Kite, release it, and it goes up quickly.
Mm-hmm.
And then what do you think about the dabble?
So it kind of, I mean, I guess I would just say it goes up and down.
Due to wind, due to
Just whatever.
whatever, however you want to explain that. And then it
It drops down to, it crashes to the ground.
I would confirm a crash.
Mm-hmm.
Okay.
And it definitely goes to the ground.
So then you continue writing that out. I think you're good with us saying that.
Yeah.
Okay.
Okay. All right. The table shows the relationship between number of t-shirts sold and the amount of profit the store makes.
Profit is how much money you make at the end.
So then, there's the question. Is the above relationship a linear function?
Okay.
So I'm going to look for a constant rate of change, right?
So that's up by 7.25.
Mm-hmm.
That's 7.25 as
Sure
well.
is.
And then I know that's 0.25, and then 14, 7.25.
Okay.
And then up 1, 1, and 1. So yes,
This
it is linear because this went up by the same, and this was up by the same.
Mm-hmm.
Okay.
So then, what is the graph? Okay, so I need to put, first of all, I need to put my variables on.
Okay.
So shirts sold is my
Got it.
X, and total profit on the side.
Okay.
Now, okay, so my shirts sold, I have to go up to 3, so I think I could even skip 3 lines. So boom, boom, boom.
3, 1, 2, 3.
That's itty bitty, so sorry.
Okay.
All right, and then my profit has to go up to $20, $22 basically. What if we go by 5s but skip a line? So really, ultimately going by $2.50. Think that's gonna work?
Sure. Yeah, maybe. 5.
Boom, boom. Yeah, 10. Mm-hmm.
We just squint hard enough.
Yeah, sorry it's so small.
Okay. So 0, 0. Love these.
Mm-hmm.
Easy.
One
1,
shirt.
750. So 5,
Or $7.25.
6, 7. So it should be right above this line, right?
Sure.
Okay.
Mm-hmm.
2, 14.50. Right under that.
Mhm.
And 3, 21. So right above it. Okay. Now, do I connect these?
I don't think so, and here's why. You cannot sell half of a shirt.
You got it.
This is a discrete relationship.
Tank top, still a t-shirt. Right?
Right.
So you can't say, oh, without the sleeves. We've heard that.
Oh, yeah. No, it doesn't work. Okay, now number 4, describe the relationship using words,
Okay.
and then what is the equation?
Okay. So again, this is done over here. If you have your labels and you have your dots pointed, you're done. You do not connect the line.
So using words, I would say each shirt costs $7.25, or shirts increase, or actually we should relate the two. So multiply the number
Well,
of.
you say you start with no shirts.
Yeah.
Okay.
0 shirts, and increase by $7.25 each time.
Okay.
Could I also say number of shirts times $7.25 is my profit?
Yeah.
That works too.
As long as you're telling us that each shirt is $7.25, you're good.
And
Okay,
then
so an equation.
then the equation would be y equals $7.25
Times a shirt.
Yeah, times X or S, or if you're using different ones, then that's fine. Okay. Okay, if you were to graph this function, would it be linear or non-linear? So I don't know what's happening.
Okay, it's fine.
Okay.
We'll work through it.
So it goes up by 0.3, what is that, 7.3?
Mm-hmm.
And that is 7.3. Is that 7.3 also?
9,
No.
11, 12.
Yeah, that's 7.3
Mm-hmm.
and 7.3. So this is linear.
Let's see. 1, 1, 1.
Oh,
Yep.
good. Okay.
Yes,
yes.
linear. And this, guys, this is how you show your work.
That's
Just that
easy.
simple. Okay.
Okay.
Ordered pairs 1, 2, 2, 5, 3, 10, 4, 17, and 5, 26 represent a function. Remember a function. One input has one output. What is a rule that represents this function? So we're asking, how do we go from 1 to 2? How do we go from 2 to 5?
Mm-hmm.
So sometimes it's easiest if you just set it up like the table.
Mhm.
Nothing, you don't have to be fancy with this.
Mm-mm. So I don't need to get out a ruler.
You don't need to. Nope. So here, guys, we're not asking how much does it go up here, how much does it go up here.
Mm-mm.
Okay, that's if it's linear. We want to know the rule. Again, how are we going from our x to y?
Okay, so the first one I could say, okay, maybe it's times 2.
Okay, I was thinking plus 1
Oh,
or
okay.
times 2.
Okay.
Okay,
The next one is it's
2 plus 1, that doesn't work.
It's not plus 1,
2 times 2, that doesn't work.
but if I did both of those together, times 2 plus 1.
What? So 2x plus 1.
Yeah, but then if I go back to the beginning one,
Uh-huh.
2 times 2 is 2 plus 1 is 3, so it can't be that.
Okay,
Let's look at the next one.
so that one doesn't work.
Okay, so this is not times 2 plus
No.
1, but it's times 3 plus 1. And the
4
next
times 4, 16
plus 1.
plus 1.
5 times 5 plus 1 is 26.
Well, isn't 5 times 5, isn't that 5 squared?
It is.
Okay.
So
So
it's-
it's 4 squared.
Yes,
It's- okay.
3 squared. Okay, so it's x squared
Mm-hmm.
plus 1.
So what does that work for this one? 1
Uh,
times 1 is
1.
plus.
Good. 1 is 2.
Got it.
Okay, so x.
So can I just write this?
No, you
A
need to
little
have
fancy.
equals y. And again, guys, there was no way that we did this without just kind of working our way through it.
Right. There
You
it
just
is.
have to like talk to yourself about it silently in your head.
Got it.
Okay, what is the graph of the function rule? So we're going to make a table. We've given you the table here. We're going to plop in. Now, this is not a real world problem.
Right.
So, and I noticed that there's no fractions involved, so I can just use my whole numbers of, well, not whole numbers, but integers, -2, -1,
Yep.
0, 1, 2.
And these are the ones that we always suggest you use, unless it's the real world, unless they're compatible, which we've talked about several times.
Okie dokie. So then we plop this in there. 3 times -2 minus 2, so that's, and yeah, let's get it filled in first.
Yeah. And you guys know how to do this. All we're doing is changing that x variable. Okay?
All right, so then we're going to have -6 minus 2 is -8.
So then my ordered pair would be -2, -8.
Yes.
Okay?
Next one is wait, 3 minus 2 is -5. Is that right? Yeah.
Uh-huh.
Okay. So
Then
then,
love me a 0.
yeah, -2.
-2. So 3 minus 2 is
1. And then 6
6.
minus 2 is 4.
Mhm.
And then we put it on the graph.
So -2, -8. Start at the origin,
-2,
left 2.
down 8.
That's harder than it looks, guys. -1, 1, 2, 3, 4, 5. 0, -2. 1, 1,
Up, up, good.
2, 4.
Okay.
Now, do I connect these?
Yes, you
Okay.
do, because since this is not a real world problem, I could have any value of x. I could have -2.3, I could have 1.4, I could have any value in between those. So,
Okay. Do I need to use a straight edge?
yes,
Okay.
and you also need to put arrows on the end.
Thank you. So, the stupid arrows, that's a point, isn't it?
Yeah,
And a straight edge, that's a point too.
Mhm.
Even if your line is completely wrong.
you could get 2 free points by using arrows and making a straight
You
line.
got it.
All right,
So
now,
let's just set up this table for them.
what?
Let's just set up the table.
And then move on. Okay, so again, this is a cell phone. You get a phone for $15 and it's 35 cents for a call planning to be made. Oh, calls that you're planning to make. And then it gives you the function. Okay, so now this is a real world problem and it tells me that I will go up to a maximum of 50 calls. So I know that my last value is 50 and I know that my first value is 0 because I can't have less than 0 calls.
Okay.
All right, so then I'm going to, let's see, so then 10, 20, 10, 20, 30? No.
No.
Well, maybe let's move it down one.
Make it an extra one?
Yeah.
Okay.
So let's do, that makes
Up
more
by
sense.
tens.
Yeah, so 10, 20, 30, 40. And then 50.
Because we need constant intervals,
Right.
right? And instead of doing like intervals of
Something weird.
13 or something, right?
Right.
Just add another
section.
section, which is fine because then you're just going to have one extra dot over here.
Right.
Okay? When you go to graph this, guys, we're not graphing this now. You should have this graphed. You only connect the two dots. You should have a dot here and a dot here. There's no arrows here because you can't go beyond what's shown.
But it's not going to look like that.
No, I was just plotting.
Okay.
Yeah, I was just plotting.
Okay. Yeah, I mean, it's going to be an increasing amount, but then you're not going to have arrows on the end because you cannot go more than 50 calls.
Right.
Okay.
Okay.
So write the function for the situation, then tell if it's continuous or discrete. So would I connect the dots or not? So a tire store sells tires for $90 each. What is the cost C of N tires? Well, in this situation, cost is going to be each tire times $90. So cost equals
Cost is
90 N.
Okay.
Now, I cannot purchase half of a tire.
right.
So I
You
would
get
not,
one or you get none.
yeah, so I would not connect the dots in this situation, which makes this a discrete relationship. Now, the produce stand sells roasted peanuts for $1.90 per pound. What's the cost of P pounds of peanuts? Okay,
Okay.
so again, same situation, cost equals $1.90 per pound, so 190 times P.
Mm-hmm.
But I can purchase half a pound if I want to. So this is a continuous relationship where
Got
I
it.
would connect the dots.
Mhm.
Okay.
So you need to have both of these items for this problem.
Mm-hmm. Okay, this is kind of confusing, and I had to
No, you're good.
smush it. All right, so we've got absolute value, y equals absolute value of x minus 1.
Mm-hmm.
So I'm still going to use my -2, -1, 0, 1, 2.
Uh-huh.
I'm going to plug it into my table.
Okay.
And one thing that I remember from the flip from last time is that absolute value graphs make a V.
Uh-huh.
Absolute value V. So it's okay if I'm going to get similar values in my ordered pairs. So
Right.
the first one is -2, -2 absolute value is 2, -1 is 1. So -2, 1. 1 minus 1 is 0. 0 minus 1 is -1. 1 minus 1 is 0 again, which is okay.
Mhm.
That's going to help me make my V. And then 2 minus 2 is 0. That can't be right.
Mm-mm.
1 minus 1 is 0. 1 minus...
Oh, this
Oh,
is
that's
supposed
to
to
be a
one.
1.
There
Yeah.
we go.
Okay. I was like, that should be
That's
1.
right, though. Yeah. Okay.
Okay.
Were you guys yelling at us?
Yeah. They're probably getting really annoyed. Okay, so 2, 1 is there. -1, 0 is there. There. And then it's going to be a mirror image.
Uh-huh. And then 2, 1.
And then I should connect my dots with
Yep.
a straight edge.
You got it?
And I should extend farther than just the dots.
Yep. Go the whole graph.
Put lines and arrows.
Done.
And I'm good. And again, it made a V.
Mhm.
Proved it to myself. Now this one, we don't need to go through the entire situation.
Nope, but just use those same numbers again.
And my graph should make a U.
So it'll be kind of a little bit tighter, something like this.
Mhm.
And again, we don't know if it's down here or up here.
It's going to be right there, I think,
Okay.
actually. Okay. Okay, the length of a piece of fabric in feet is a
1 minute.
Okay. Well, why don't we stop here?
Check us on part 2.
Yeah, we'll see part 2.